So direct variation is a very, very specific type of equation. You guys are going to like it. It's as simple as it gets, in my opinion, okay? And an equation is a direct variation equation if it is of the form y is equal to something times x. So if I say two things very directly, what that really means is those two things are separated by one multiplication problem. Okay, that's it. So if I tell you that y varies directly with x, and I ask you to, so we call this k the constant of variation, but really, it's slope. Okay? K is essentially the slope, and something is direct. We kind of talked about this yesterday. A direct relationship is a relationship where 0 and 0 go together, a y-intercept of 0. And if we think of y equals mx plus b, can we see that this is like mx, and then this plus b would be 0 if the relationship is a direct relationship. Okay? So the first thing I might ask you to do is find just that constant of variation. Find k. All right? So if I tell you that y is equal to something times x, because y varies directly with x, and then I say, and I happen to know that when y is 12, x is equal to 2. Can you guys tell me what that constant would have been between the two? And if I asked you to write the direct variation equation, we would rewrite that as y equals 6 times x. So this is k. This is the equation. So let's go ahead and say somebody has a job in which they get paid $10 an hour. Is everybody with me?
Yes.
Is that a direct relationship?
Yes.
If you work 0 hours, you get $0. And honestly, we could say their pay is equal to 10 times their hours. Does that make sense? And so sometimes they might work 5 hours, and sometimes they might work 3 hours, and sometimes they might work 10 hours. And each of those equals a different amount of money. Make sense?
Yes.
All right. So the reason we need, k just tells us like that rate. The equation tells us like this general formula that we can then use in the future. That's the goal. All right. So guys, what is k for this problem? $4.5. And if I asked you to write the equation, how do we get that 4.5?
Miss Meister?
Yeah.
Wouldn't it just be 6? No.
So we're going to divide both sides by 4.
Yes.
18 divided, if it were 3, it would be 6.
Right.
So this is a different situation, yeah? Okay, so now I get 4.5 equals k. So my equation is y equals 4.5x. Why don't you guys try the next two? Did we do okay? Cool. All right, so next what we're going to do is some similar questions, right? Okay, and so what if I tell you y equals 6 when x equals 4? Let's go ahead and find that k. So we'll have 6 equals k times 4. K equals 1.5. Is everybody good with that? So my first solution that we started with was the 0.46. And we now have an equation that is y equals 1.5x. So let me go ahead and plot 4, 6. Can somebody tell me another solution to that equation? Keeping in mind that that solution, since the equation has two variables, would have two values. An x value and a y value. What's another x and y that make this equation true? Yeah. So the solution would be x was 1 and y equals 1.5. Yes? So you said 1.5 equals 1.5 times 1, right? Where this is your x and this is your y. Cool? So the 0.1, 1.5 is right about here. What's another solution? A different number. If we plug a different number in for x, what do we get? 2. And if we do, what value for what? Like, what value for y corresponds with x equaling 2? 3. Now, when you look at this, y'all, do you guys see a line that goes through the point 0, 0? Okay, so do we see how this is a direct relationship if we look at a graph of these solutions, the y-intercept 0? And what's the slope of the line? Let's see, that's going up 3 units and going to the right 2. So 3 halves? Does this make sense? All right, can you guys find a couple of the equation and graph and solutions to this set? Different value for k now. Thoughts? We feeling okay so far? Can the graph help us find solutions? Can the solutions help us find the graph?
Yeah.
Yeah? It all works hand, like, it's not like one is better than the other. Cool. They're just different representations. Cool.
72.
All right. Now, the whole purpose of this, honestly, is that we use direct variation reasoning all the time. So, the distance from lightning varies directly with the time it takes you to hear thunder. Have you guys heard of this? Yes? That if you count how many seconds or whatever, it can help you figure out how far away a thunderstorm is? Okay. If you hear thunder 10 seconds after you see lightning, you're about 2 miles from the lightning. Okay, so here's the deal. Distance varies directly with time. Do you guys see how I put that in context to help me with this? Yes? Okay? So now, if I ask you to write the equation, I want to know what is the answer after, or like what equation can we use to fill in and figure stuff out? Okay? So, I need to figure out what is that value for k. So what am I going to fill in for the distance? Equals k times, my time in this case is 10. So my constant of variation here is 2 over 10. Which you could either write as 1/5 or 0.2. I do not care. Okay. But that's not my answer. My answer is that the distance is equal to 0.2 times the time. All right. Now that we have this, estimate how many seconds it would take for the thunder to travel 4 miles. So we'd say 4 equals 0.2 t. Hopefully we're getting 20 seconds. And guys, does that make sense? If it does 2 miles in 10 seconds, it's going to take twice as long to go 4 miles. Okay? All right. Do you think I need the labels on that? Yeah. The whole point of this is that we're recognizing this is a concept in a context, so that we care about that context. All right? You see a flash of lightning and hear thunder about 18 seconds later. How far away was the lightning strike? So this time, what do we know? We know the time. So I'm going to take that same equation and plug 18 in for the time.
Miss Westby,
Mm-hmm.
where did we get 0.2 from?
The original where we knew the seconds and the miles for one value, so we found the k. And then we ended up with this equation. You with me? This equation?
Yes. I'm just tired of the day.
Right on. Yeah. 3.6 miles. Yeah? 3.6 miles?
Just thinking about if Miss Clayton has to.
Are you working tonight?
No.
Okay. You said tea.
I know, I was thinking
All right. A recipe for 2 dozen corn muffins calls for 3 cups of flour. The number of muffins varies directly with the amount of flour that you use. Does that seem reasonable? Yeah. Okay. So, first of all, I'm asking you for a relationship between the number of cups and the number of muffins. Okay. How many muffins did those 3 cups of flour make?
24.
Is everybody with me on that? And by me, I mean Mackenzie. 2 dozen means a total of 24 muffins. Yeah? Okay. So we know that the muffins vary directly with the cups. Okay? So once we find K, we can use that equation to help us over and over and over again. So we know that 24 muffins is what happened when we had 3 cups. What does that make K? All right. So my equation to model all of this is that that my number of muffins is equal to 8 times my number of cups of flour. And once we find that equation, it's like my permanent equation that I can work from for this context. Okay? So, how many cups of flour need to make 6 muffins? Or 6 dozen muffins? Oh boy, guys. 6 dozen is 72. Okay. And so we would have our number of muffins equals 8 times how many cups of flour? Nine cups. All right. How many muffins can I make if I only have 5 cups of flour? Take my number of muffins equals 8 times the 5 cups of flour. 40. How are we feeling about this?
Fantastic. Is this gonna get harder? It has to.
So your graded assignments today, I'm going to ask you to do 2 things. Some practice with this kind of stuff and